So now, last time we started with something called as complex number. Okay, what is a complex number? Any complex number can be represented by a letter called as Z. Okay, so Z is equal to A plus IB will be a complex number. If you see here, Z is equal to A plus IB, where A is called as real part and B is called as imaginary part. Okay, and after that you have seen that, for example, if Z is equal to 3 plus 4i, 3 would be called as real part and 4 is called as imaginary part. In simple terms, whichever number is combined with I, or whichever part is with I, that part is called as imaginary part. Okay. Then we went ahead and we saw that what is called as complex conjugate. Complex conjugate of any complex number is nothing but sign reversal of the original complex number. If you have, let's say, Z is equal to A plus IB, its conjugate will be given by A minus IB. It means sign reversal of imaginary part gives you complex conjugate. For example, if you have, let's say, Z is equal to 3 plus 4i, its conjugate Z bar will be 3 minus 4i. Okay, that was conjugate. Then there are certain results. Okay, Z bar is equal to Z, but the most important result in complex number is the second one. Second one is, if you want to get real part of any complex number, you can obtain by this formula Z plus Z bar upon 2. Addition of complex number with its conjugate divide by 2 will give you its real part. The same way, if you want to obtain imaginary part, Z minus Z bar upon 2 will give you imaginary. This is the most important formula as far as this complex number is concerned. Okay. And then we saw certain operations like addition of a complex number, subtraction of complex number, multiplication of complex number, and division of complex number. Now, what is addition? Addition of two complex numbers. For example, there is one complex number, Z1 is equal to A plus IB and Z2 is equal to C plus IB. When you want to add them, so addition of their real parts will give you A plus C. Addition of their imaginary part will give you B plus B. So, just like you can add mangoes with mango, the same way the concept is extended to addition of real numbers with real number and imaginary part with imaginary part, and you get A plus C plus I B plus B. That is how addition of two complex number takes place. Now, we go for differentiation of two complex numbers. So, if the first one is Z1 is equal to A plus IB and the second is Z2 is equal to C plus C minus IB, so you'll add A minus C since their real parts are A and C, and B minus B, and the bracket will have I outside. Similarly, if you have to do multiplication will be a very normal bracket multiplication, like you have to multiply A plus IB to C plus IB, a very normal multiplication where A is multiplied with C, A is also multiplied with IB. Now, IB is multiplied with C and IB is also multiplied to IB. A very normal multiplication that we used to do. The last term will have I squared. The most important part in complex number is to always replace I square by minus 1. You replace it by minus 1. As soon as you replace it by minus 1, this becomes minus BD and this becomes entirely real. So AC minus BD, and these two parts being imaginary, they will be written together. So you'll have I outside AB plus BC. Okay. So this is the most important part in multiplication of complex number. Or else there is one more thing. You can do. You can write A, B, C, D. Okay, and AC minus BD cross multiplication and AD plus BC. So these are the shortcuts that will come on later on. For example, now suppose if you want to do division of a complex number. In division, there are two complex numbers, A plus IB, and the second one is C plus IB. Now, always concentrate on the denominator part. Your denominator is C plus IB. For solving division part of any complex number, you need to multiply and divide that complex number by its conjugate. What is conjugate? Sign reversal of the denominator. Sign reversal means reversal of only imaginary part. So you have multiplied this with C minus ID, C minus ID. The numerator part will be very normal how we do. But here you can see that it is C plus ID into C minus ID. We have learned in 12th or 10th standard that A plus B into A minus B is A square minus B square. But here we'll do reverse. We'll do a mistake. By mistake we'll write it is A square plus B square, because when you do A square minus B square, you'll get C square minus ID the whole square. You'll get C square minus ID the whole square. And when you open that bracket of ID the whole square, I square being getting replaced by minus 1, you get C square plus B square. So all of this we have studied yesterday. All of this. Now, this was day 1 of complex number. Day 2 begins with polar form. Polar form. Now, what is a polar form? For simplicity. Now, we had complex number being represented as Z is equal to A plus IB. Any complex number you can write as A plus IB. Now, there is another way of representing it. That is called as polar form. If you know, for example, there is a complex number, say Z is equal to 3 plus 4i. Any complex number can be represented in polar form. Now, how is polar form written? Polar form is having two parts. One is called as modulus, another is called as amplitude or argument. Okay, first thing is modulus, second is amplitude or argument. Now, if you want to write modulus, that is represented by R is equal to root of A square plus B square. Okay, R is equal to root of A square plus B square. Whereas the amplitude is known as theta. Theta, or it is also called as argument of Z, and it is represented by ARG of Z is equal to theta is equal to tan inverse of B upon A, or tan inverse of imaginary part upon real part. That is how we should learn. Tan inverse of imaginary part upon real part. So that is argument, and this is modulus. Modulus is represented by small r. It is represented by small r. So two things are very important. If you want to represent r, or if you want to represent polar form, so you need r and theta. Okay? Just like if you want to make vada pav, you need pav and vada. The same way, if you want to have polar form, two things are needed. Two things, r and theta. So r is obtained by root of and theta is obtained by. This should be very clear. This should be very clear. Rn theta for polar form. Okay. Now let's see how many of you can check this. For example, I am giving you very simple example. If there is a complex number 2 plus I, my example is z is equal to 2 plus I is a complex number. Okay. Now what will be modulus for that? Root of 2 square plus 1 square. That is my R. R means mod. R means mod. What will be its argument? Theta. Tan inverse of 1 upon 2. Imaginary part upon real part. If you do reverse, that comes under a special category called as Apna Apna maths. That is specially designed by students. Okay, so maybe you have got your own way of developing maths and writing theta like tan inverse of A upon B. It should have been B upon A. Have you all got how to which two parameters are important for polar form? R and theta. Formula of R is root of A square plus B square. Formula of theta B upon A. Now these two are equivalent. These two are equivalent. It means you can write complex number in this form A plus IB or this form R into cos theta plus I sin theta. Z is equal to A plus IB, or in polar form you can write it as R cos theta plus I sin theta is called polar form or modulus amplitude form of a complex number. Is this clear? Yes. Now theorems we can do later on. Before that, there is a Euler formula. Now what Mr. Euler did, he knew that people are going to struggle about writing of this entire R cos theta plus I sin theta. Okay. So what he did is, there is a formula of exponential e raised to I theta. E raised to I theta. E raised to I theta can replace this entire big term. It can replace this entire big term which was cos theta plus I sin theta. If you don't want to write cos theta plus I sin theta, you can simply write e raised to I theta. For example, if your complex number was 2 into cos 30 plus I sin 30, you write 2 e raised to I 30. Writing e raised to I 30 means you're writing cos 30 plus I sin 30. If you get confused that whether cos will come first or sin will come first, alphabetically, which is coming first, C or S? C. So C will come first. Alphabetically, you know that in alphabet C will come first. That is why you write cos theta plus I sin theta. Generally, most of you, they are inventors of new mathematics, or I must say modern mathematics, which is their own invention. They write I cos theta plus sin theta. That is absolutely wrong. You cannot write. So please write cos theta plus I sin theta, and you can replace this by R into e raised to I theta. Simply, if you want to squeeze this term, it was bigger, you wanted to write it smaller, so you write e raised to I theta, and this is what is called as Euler's rule. This is called as Euler's rule. Okay? If R is r cos theta plus I sin theta. What will be r into e raised to minus I theta?
Cos theta
It will be cos theta minus I sin theta. Now shortcuts will begin to introduce. Okay, but remember, all of you, mathematically, how it is coming out to be cos theta minus I sin theta. Now we'll take one more example how to study this better, and maybe we can just take help of this notebook and solve it. Okay. Now, for example, let's say r into e raised to I theta. Okay. This was our polar form. So I'll write z is equal to r into plus I sin. This is called as Euler's rule. Now, z can be, if it is e raised to I theta minus, what happens is you write cos of minus theta plus I sin of theta. Now, here what happens is, if you have cos basically, it is a good person, okay? So, whenever the negativity is with cos, it will not change its nature, it will become positive. But sin is very negative. Even small amount of negativity will make it more negative. So minus comes outside and you can write minus. So that is one way of learning it. Okay. So that is how basically directly you should think. Okay. In a bucket. Okay. You have 2 apples. Okay. And 4 bananas. Later on, if you add more bananas, obviously banana will be added with banana. The same way, you have real part, you have imaginary part. You have real part, you have imaginary part. So directly you can add 2 plus 4. 3 minus 5. Now in this particular PDF, what they have done is, they have added it very systematically. They have collected all the terms which are without I and the terms with I. Very systematically they have bifurcated the terms with without I, and with I. So without I is 2 plus 4, that is 6. With I is 3 minus 5, that is minus 2. That is how you solve. Now I don't think there should be any doubt in this. Just try to see how we can solve this on the similar lines. Very simple.
Yes, sir.
2 times z1 will give you 6 minus 8. 3 times this will give you minus 6 plus 9. Okay. And when you open the bracket, since minus outside is there, so it will give you 6 minus 9. Now you have got this. So addition of 6 plus 6 is 12. Minus 8I minus 9I is minus 77. Now how we can do multiplication? Multiplication is very simple. In multiplication, there are 2 brackets like A plus B into C plus D. A plus B into C plus D. So multiplication of A with entire bracket, multiplication of B with entire bracket will give you 3 4s are 12, 3 2s are 6i, 2i into 4 is 8i, 2i into 2i is 4i square. Always remember, in complex number, whenever you get I square, you must replace that by minus 1. So when you replace it by minus 1, This becomes minus 4. Why I am telling you to replace I square by minus 1 is I square term is a real term. I square term is a real term because I square being minus 1 will make this term as real. And hence you will add 12 minus 4, so you get 8 with 49. Bringing all the terms with I together, without I together, and then doing addition and subtraction. Now, just now we saw how to do division. Do you think it is division?
Yes.
What is there in the numerator?
1.
What is there in the denominator?
3
I said अर्जुन की जो आंख है वो कबूतर देखिए वैसे होनी चाहिए. अब देखो यहाँ पे 3 plus 2i. 3 plus 2i. What is the conjugate of 3 plus 2i?
3 minus 2i.
Some people, they do their invention with years of hard work. They write minus 3 minus 2i. Conjugate is obtained by reversing sign of imaginary part. So it shall give you 3 minus 2i. Multiply and divide. And in division, just focus on denominator. Just focus on that. Close your eyes and you can write a square plus b square. That is 9 plus 4, that is 13. Need not worry about anything. Nothing can be simpler than this. Nothing. Now it's a thumb rule. Whenever I get any kind of division in complex number, I shall focus where?
Denominator.
What is that? What will you do?
Conjugate of denominator.
Where do you focus?
Denominator.
Next is a square plus b square. That is 9 plus 4. That is 13. That is sorted. Right from start you can write 13. In numerator you solve normal. 1 into 3 minus 2i into 3 minus 2i. And then you can separate. So the real part of finally obtained complex number is 3 upon 13 minus 2 upon 13i. Is this clear? Yes. So that is how you solve a real number. And now all of you can see the next question also. Yes. Step 1. What is to be observed in division?
Denominator.
Okay. Step 2.
Conjugate of denominator.
Conjugate.
Of denominator. 1 minus I.
My doubt. What can be conjugate of 1? Remember, for finding conjugate, we reverse imaginary part. Since number 1 doesn't have any imaginary part, so its conjugate will be 1. Now let's focus on this particular question, which is 1 upon 1 plus I. If there is 1 plus I in the denominator, how will you solve this? Multiply and divide by
1 minus I.
Is
1
a plus b?
1 plus 1.
A square plus b square, that is 2. Now, find the modulus and amplitude. Modulus and amplitude, as I have taught you, it comes in polar form. So, if you have 1 plus I being the complex number, so we write let z equal to 1 plus I. Real part is 1, imaginary part is 1. The formula of modulus is root of a square plus b square. And amplitude is tan inverse of 1. We all know that tan 45 is 1.
Yes.
So that is why tan inverse of 1 will be
45 degree.
These were some of the basic examples of complex numbers. Now, this is not very difficult. Just in 2 minutes you can solve.
Yes.
Just in 2 minutes. Step 1. Is it? There are 4 operations possible. Addition, subtraction,
Multiplication, division.
Okay. And most of the times division is asked. Most of the times. Step 1. Concentrate at the
Denominator.
Step 2. Multiply and divide by.
Denominator.
You multiply and divide. Now I will not repeat how to write conjugate. Step 3.
A square plus b square.
Although it is a minus b into a plus b, but since it's a complex number, 3 square minus 2i the whole square will give you 3 square plus 4 square. So 3 square plus 4 square.
2 square.
3 square plus 2 square will give you 30. Okay. Now the numerator bracket will be solved normally. 4 3s are 12, 4 2s are 8i, 5 3s are 59, 5i into 2i. Whenever there is I square, collect all the terms without I. 12 minus 10, 2. So this is the real part. This is the imaginary part. I hope things are very clear.
Yes, sir.
And Abhi, this is actually combination of 2 examples in one. This example is addition of 2 separate divisions. This example is addition of 2 separate divisions. But the rule will remain same. Rule will remain. Can you see? Yes.
Yes.
Now observe this, all of you. I guess now there are similar examples. So that will not repeat. This is a bit different. Whenever it is said find modulus and argument, which form of complex number is that? Polar form. Are you all clear about it?
Yes.
Whenever modulus and argument are asked, it is about polar form. What is the formula of modulus? Root of a square minus b square. What is the formula of theta? Tan inverse of
B upon A.
You have to solve this normally. How you should solve? Towards the end, you will get one real part, you will get one imaginary part, and then you have to put that in the formula. Is it division?
Yes.
Step 1. Step 1. Divide the denominator. Look at the
Denominator.
Step 1. Look at the denominator. What is the conjugate?
3 minus 2i.
Yeah. Now close your eyes. And for the denominator, a square plus b square. So root of 3 square.
3. 4.
7. Very, very important. Do not even can solve this much. Directly write from this step 777, 777. Now, in the numerator, normally you can solve 1 into root 3, root 3. 1 minus 2y, minus 2y. 3 into root 3 into root 3. 9. Minus 2 3s are 6 root 3 I square. Whenever there is I square, whenever there is I square, it will become plus. Collect all the terms without I. 6 times root 3, 1 time root 3.
7 root 3.
6 times root 3, 1 time root 3.
7 times root 3. Plus 7 I have.
Now separate.
Root 3 plus I.
Now a plus ib form आ गया.
Yes.
But you wanted polar form. You wanted polar form. Now you can observe by yourself. With this we come to the end of this session.